Hey, what's up mga bis? So we're back for another example of our bending or flexural stress. Pero ngayon naman, ang isosolve nating mga example ay yung mga may cross-section na beam na unsymmetrical. Let's go! Okay, so ito yung problem. We should determine the maximum bending stress in the beam AB. Ito yung biga. Shown in the figure and draw the stress distribution over the cross-section at this location. So, i-draw down natin yung stress distribution. Of course, that's bending stress, no? Bending stress doon sa location kung saan natin malolocate ang maximum bending. Alright. So, ano yung magiging strategy natin ngayon? First, ipakita ko muna yung formula ulit. Mag-start tayo mag-analyze from the formula. Okay? So, tignan natin kung ano yung meron tayo, ano yung wala, para alam natin kung ano yung isosolve natin. So, itong sigma or the bending stress, ito yung hinahanap natin. That's the maximum bending stress, right? Next, itong M. Itong moment na to mga bis, this is the maximum moment. Okay? So, since unsymmetrical na yung ating cross-section, therefore, we will now consider our maximum positive moment and also the maximum negative moment. So, kukunin natin yung dalawang yan. Okay? So, di ba kasi kapag symmetrical, yung kinukuha lang natin is the absolute maximum. So, the sign doesn't matter. Pero dito mga bis, it matters. We need to consider both positive and negative. So, dalawa yung kukunin nating maximum moments. Okay, itong C mga bis, hindi na yan implied kasi hindi na siya symmetrical, di ba? Kasi kapag symmetrical to, alam na natin yung location ng neutral axis, which is dito sa eksaktong center niya. So, kapag kukunin natin yung C, that's just this length, right? Pero unsymmetrical yan. So, hindi natin masasabi na ang neutral axis niya lies exactly at the center. Mali yun. Okay? So, isosolve din natin kung ano yung neutral axis niya. And then lastly, itong ating I or the centroidal moment of inertia. Since symmetrical na siya, kailangan na natin gumamit ng parallel axis theorem para mas-solve yung ating centroidal moment of inertia. So simulan muna natin sa paghanap nitong M or the maximum positive and maximum negative moment. And how we will do that? We will use shear and moment diagram. So kukunin ko lang to and ipa-plot natin ang shear and moment diagram niya. Okay, ngayon mga bis, let's solve for the maximum positive moment and the maximum negative moment. Pero bago tayo makaproceed doon, solve muna natin yung reactions. Kasi kung makikita nyo, unknown sila, di ba? Yung reaction at A and reaction at B. So this is RA and this is RB. So how do we solve for that? We use equilibrium equations. Summation of moments with respect to B, simulan natin sa B, is equal to 0 considering that clockwise moments are positive. So we have here reaction at A. Yung reaction at A natin, it will create a clockwise moment. So, positive yan. RA times yung distance niya towards B. That's 3 and 2. So, 5. And then, we have here a distributed load, diba? Distributed load which has a magnitude of 10 kN per meter. Now, to convert this into a point load, kukunin lang natin yung area ng rectangular load na to. Yan ay magiging 10 times the total length which is 5 meters. So, magiging 50 kilonewton na lang to. Now, this 50 kilonewton will create a counterclockwise moment kasi B yung reference natin eh. Iikot siyang pag ganon. So, since counterclockwise, negative yan. Negative 50 times ano yung distance niya punta sa dulo. Since rectangle lang yan, nasa kalahati. So, ano ba yung total length? That's 5. 5 divided by 2 is 2.5. Therefore, 2.5 yung perpendicular distance to B. Okay? And then, we proceed here. This 75 kilonewton point load. Parehas din, it will create counterclockwise moment. So, negative 75 times, ano yung distance niya towards B? That's 2 meters. Equals 0. Now, we can solve for RA. RA is equal to, this is equal to 150 plus 125 is equal to 275 divided by 5. 275 divided by 5 is equal to 55. Okay, so RA is equal to 55 kilonewtons. Okay, kilonewtons. Now, to solve for RB, summation of forces na lang tayo along the vertical direction. So, upwards forces are positive. So, we have RA, which is going up, so positive. Then, we have also RB na pataas, so positive rin. And then, yung mga downward forces, we have 50 and 75. Minus 50 minus 75 is equal to 0, thus, RB is equal to, okay, so RB is 70 kilonewtons, and we can write them here. Our RA is equal to 55 kilonewtons, and our RB is equal to 70 kilonewtons. Ayan. So, dito, starting from 0, makikita natin may RA na pataas, which is 55. So, we go up 55. And then, we have here a distributed load. Diba? So, ano yung area niyan? That's 10 times 3. So, 30. Pero pababa. So, from 55, we will subtract 30. So, magiging 25. Okay? And we will connect that using a first degree line. So, straight lang yan. And then here, at this point, meron tayong 75-point load, pababa. So, 25 minus 75 would be equal to negative 50. So, bababa tayo at negative 50. And we connect that. And then next, along this length, mga bisno, meron ulit tayong distributed load. Ang area niyan would be equal to 10 times 2, which is equal to 20. And since pababa, we will subtract that to our existing value. So, negative 50 minus 20 is negative 70. Let's say, andito yan. And then, connect that via first degree line. And then, at point B, meron tayong RB, which is a value of 70 kilonewton pataas. So, magka-cancel yan. Magiging 0 na. Okay? So, ito yung ating shear diagram, mga bis, no? Okay, so punta tayo sa ating moment diagram. Starting from 0, we solve for this area. This is a positive area, right? So, this is a trapezoid. So, solving for that area, that's 20 base 1 plus base 2 divided by 2 times height. So, 25 plus 55 divided by 2 times, ano ba yung height niya? That's 3 meters. So, times 3. That would be equal to 120. So, from 0, aakyat tayo sa 120, and it will be connected by a line like that. Okay, so, gamitin lang natin yung technique ko, bird mountain diagram. Okay, so, yan, pag ganyan po siya. Ito siya, yan pag ganun. Kasi yung pinanggalingan niyang line is pag ganun, which is andito rin. Okay, so next, we have here our next area, which is also a negative area. 50 plus 70 divided by 2 times, ano yung height natin? 2 rin. So, magiging 120. Pero negative area, so babalik siya sa 0. Okay? So, from 120 minus 120, pupunta siya sa 0. Okay, so, ito yung ating shear diagram, ito yung ating moment diagram. Okay, ngayon, ano ulit yung hinahanap natin? It's the maximum positive moment and the maximum negative moment. Pero, kung makikita natin, wala tayong negative moment, we only have a positive moment. In that case, okay lang yun. Hindi natin problema yun. Okay? May mga instances talaga na meron ka lang positive moment or meron ka lang negative moment. So, kung anong meron, yun na. Pero kung, for example, meron kang negative moment, then you consider that, for example. Pag ganon, then meron to, di ba? You consider that negative moment. Pero in this case nga, wala. So, ito lang yung gagamitin natin, which is 120 kilonewton meter. So, yan yung ating maximum positive moment. And, ano yung magiging itsura niyan ng ating beam? Ang magiging itsura ng ating beam kapag magdi-deflect na yan, kapag magbe-bend na yan, would be like that. Okay? Magiging ganun siya. Ayun. So, parang invert lang natin yung ating moment diagram. Therefore, masasabi natin na at this point, yung magiging itsura ng ating beam pag magbe-bend ay ganun. Okay? So, at the top, you will have compression, and at the bottom, you will have tension. So, tensile stress, compressive stress. Now, let's get back to our problem. So, nasolve na natin yung M. Check na yan. Okay na yan, no? Alam natin yung ating moment. Now, para ma-solve yung ating C at yung I, punta na tayo sa ating cross-section. Kailangan muna nating mahanap kung saan yung neutral axis or yung centroid ng section natin. Kung saan yung neutral axis niya. Itong location nito, okay? Pero for now, we will set a temporary reference point and let's set that at the bottom, okay? So, para mahanap kung ano yung distance ng ating neutral axis going to the bottom, we will set here a coefficient of bar y. So, itong bar y, ito yung isosolve natin para mahanap natin yung location nitong ating neutral axis. Okay, so anong gagawin natin? Bar y would be simply equal to, nanggaling to sa statics, the summation of area times y divided by the summation of the areas. Okay, so ano tong area? Area would be the area of each part. Okay, so kukunin natin na isang part to. Yan. This first part. And we will get this as our second part. So, itong A would be the area of this part. And what is this Y? Y would be equal to the location of the centroid of this certain portion or this certain part going to our temporary reference point, which kung saan sinet natin na sa bottom. Okay, so this temporary reference point can be anywhere. Kahit dyan or dyan, pwede yan. Pero mas easier kasi kapag nasa bottom. Okay, simulan natin. Remember, meron tayong dalawang parts. Simulan natin dito sa pinaka-top. So, ano yung area niyan? Ang area niyan would be equal to 175 times 50. So, I believe these are in millimeters. So, that's 175 times 50. Okay, so yung top portion lang na to. Okay, and then, we multiply the y or the distance mula dito sa centroid niya papunta sa ating temporary reference point. And yung centroid nito is located, di ba, is sa kalahati ng distance na to. This is h over 2. Ano ba yung height niya? 50, di ba? So, ibig sabihin ito, 25 lang. So, ano ngayon yung distance from dito naman, papunta sa pinaka-bottom? That would be equal to 150. So, 25 plus 150 is 175. Okay? Yan. Plus. Kasi nga, summation tayo, di ba? Next, dito naman. Ano yung area ng portion na to? This is equal to 50. Ayan. 50 times 150. Okay. Now, we will need to multiply again the y. Ano yung y niya? That's the distance from the centroid dito papunta sa ating reference point. This is at the bottom. So, since 150 yung total nito, i-divide lang natin sa 2. So, ibig sabihin, mula dito papunta sa bottom, that's 75. Alright? Over summation of areas. So, we will add the areas of each figure that we had. So, first ito, that's 175 times 50, yung taas na to. Tapos ito, 150 times 50 plus 150 times 50. So, the answer of this, so ang sagot po natin mga Bs ay equal sa 128.85. Okay, so I'll go to decimal. So, the location of our neutral axis is 128.85 from the bottom. Okay, so ito, pwede natin yung bigyan niya ng length. That's 128.85. Okay, so these are in millimeters. Okay, so that's mm. Okay mga bis, so alam na natin yung location ng ating neutral axis. Balik ulit tayo dito. So itong C, we can now solve for that, right? Kasi kung ito yung ating neutral axis, our C would be this length and also this length. Okay, so bakit dalawa na yung C natin? We will solve it twice kasi nga hindi na sila symmetrical, hindi na equal yung value ng C. Okay? So, iba yung value ng stress sa pinakataas, iba rin yung value ng stress sa pinaka-bottom. That's why we will have two answers and we will need to compare those para makita natin kung ano yung pagkakaiba nila. Alright? So, okay na tayo sa M, okay na tayo sa C. Ngayon, punta na tayo sa ating I, our centroidal moment of inertia. Okay? So, paano natin ito isosolve? Diba kapag symmetrical, yung ginagawa lang natin is kinukuha lang natin kung ano yung shape. Diba kapag rectangle lang yan, para makuha yung centroidal moment of inertia, that's just base times height cube over 12, diba? Pero dito, hindi na yun applicable kasi nga, hindi na siya symmetrical. Therefore, ang gagawin natin, we will use the parallel axis theorem. Okay? So, ito, para makuha natin yung centroidal moment of inertia, using parallel axis theorem or transfer distance method, kukunin natin by parts. So, una, this is the first part. And next is this the second part. So, I top, tapos I plus I bottom. Okay, so yung baba naman. So, unahin muna natin to, tapos next is ito. So, i-add lang natin yung centroidal moment of inertia ng dalawa na yan and we will get our total centroidal moment of inertia. So, paano natin yan gagawin? Since the shape of this figure is rectangle, we will have base times height cube over 12. Plus, anong i-add natin dito? I-add natin dyan yung area ng figure Tapos, times y squared. Ano itong y? Will be equal to the distance mula sa centroid ng figure papunta na ngayon sa ating neutral axis. Ito. Okay? So, papunta na dito yung y na yon. Alright. So, tanggalin muna natin yan. So, dito sa bottom figure natin, rectangle pa rin yan. So, gagamitin pa rin natin yung base height cube divided by 12 plus yung ay squared. Yung area nito times yung y, which is the distance dito mula sa sentro niya papunta sa ating neutral axis. Okay, so simulan natin dito sa top. Ano yung base niya? Ito, that's 175. Ano yung height? Ang height niya is just 50, so 50 cube divided by 12 plus, ano yung area niya? That's 175 times 50, right? So, 175 times 50. Ano yung y, or the distance from our centroid to the neutral axis? That would be equal to, since ito 128.85, edi yung natitira na lang dito ay equal sa solve natin. Kasi di ba yung buong yung buong ito ay 150. And kapag 128.85 lang, isubtract na lang natin. 150 minus 128.85. Yung natitira lang na to is 21.15. Okay, so 21.15. Therefore, 25 plus 21.15 would be equal to 46.15. So, yung y natin is 46.15 squared. Kasi yun yung distance mula sa centroid niya papunta dito sa ating neutral axis. So, 25 plus ito. Dito na tayo sa ating I bottom. So, sa bottom portion, bottom figure natin, ang base na ngayon ay 50. Ang height niya ay 150. So, that's 150 cube divided by 12 plus, ano yung area niya? That's 150 area. 150 times 50. Ano yung value ng y? Y is the distance dito mula sa centroid papunta sa ating neutral axis. So, kapag i-analyze natin yan, yung centroid niya is located, yung buong to, di ba? Yung buong to ay equal sa kalahati ng 150, which is equal to 75. Para makuha natin yung distance lang, yung ito lang, okay? Yung ito lang na distance, isusubtract natin yung buong 75 minus sa 21.15. So, 75 minus 21.15, we will have 53.85. So, ito, 53.85 lang yung from centroid na to papunta sa ating neutral axis. So, 53.85. So, dito times 53.85 raised to 2. So, squared siya. Okay, so ayun mga bis, pwede na natin siyang ma-solve. I-calculate na lang natin yan sa ating calculator. So, ayun talaga, no? Medyo mahaba talaga siya kapag unsymmetrical, mga bis. We have no choice, no? Ang sagot natin, mga bis, ay equal po sa 5, 6, 2, 7, 0, 0, 32.29. Ang unit po natin ay millimeter raised to 4. So, ang mga unit yan ay millimeter. So, since yan, no, millimeter cube times millimeter would be millimeter raised to 4. So, nakuha na natin yung ating I, or centroidal moment of inertia. So, balik tayo sa formula natin. Okay, nakuha na natin yung M. Nakuha na natin yung C. And nakuha din natin yung I. Okay, ngayon mga bis, sarili na tayong mag-solve ng ating bending stress. Pero, remember, we will have two answers for our bending stress. Okay? Bakit 2 yung value ng ating bending stress? Kasi, meron tayong dalawang value rin ng C. Bakit kamo? Kasi ngayon, yung neutral axis natin is hindi na sa sentro nito. Kasi unsymmetrical na siya eh. So, ang ating unang C is this first C, and ating pangalawang C ay equal dito. Kasi diba, kapag symmetrical sila, equal yan. So, iisa lang yung makuha natin value ng ating bending stress. Pero since unsymmetrical nga siya, dalawa. So, magkakaiba yung value ng ating stress dito sa top portion tsaka yung value ng stress dito sa ating bottom portion. So, that is true kapag unsymmetrical. Kapag symmetrical sila, doon lang yan magkakaparehas. Okay, so ano ba yung dalawang value ng ating C? Again, yung ating neutral axis, ito, is located 100, ano ulit yun? That's 128.85 from the bottom. Okay, so 128.85 0.85. Ayan. Ito would be 128.85. So that is our first C. And our second C dito would be equal to, ano ba yung total nito? That's 200, right? So 200 minus 128.85, we have 71.15. Okay mga bis, ngayon kung maaalala nyo, di ba yung ating beam will bend like that? Di ba? And the value of that in the moment is 120 kilonewton per meter. So balik tayo dito. Ang magiging bending yan is pag ganon. So sa taas, compression. So sa baba, tension. And ang value ng ating moment is a positive moment. That's 120 kilonewton meter. So let's start solve. First is at the top, no? At the top where there is compression. Merong compression, compressive stress. That our sigma would be equal to anong value ng ating moment? That's 120 kilonewton meter times ano yung value ng ating C sa top, ito. That's 71.15 divided by ano yung value ng ating I? Ang value ng ating I, mga bis I. Ano yung na-solve natin kanina? Ano yan? Ito. Wait, copy ko na lang. Hindi ko ma-memorize. Okay, so balik tayo dito. Ayan, ito yung value ng ating moment I. Okay? So that's 556,270,032.29. So this has a unit of millimeter raised to 4. Ito rin, millimeter din yan. So mga bis, we need to have unity of units, and I want that my final answer will be Newton per millimeter squared. Kasi this is also equal to MPa or megapascal. I-convert natin itong kilonewton meter. And conversion factor, gagamit tayo ng 1,000 newtons is equal to 1 kilonewton. And 1,000 millimeters equal to 1 meter. So, cancel kilonewton, kilonewton, and meter, So, we are now ready to solve. Therefore, the value of our stress at the top where there is compression is equal to, our answer would be equal to 151.73, no? 0.73 megapascal or Newton per millimeter squared. Okay? So, this is the value of the stress dito sa ating top. So, it is a compressive stress, right? Kasi, yun, dahil dyan sa ating bending behavior na to. Ngayon, isolve naman natin yung stress dito sa bottom. At the bottom where there is tension or where there is tensile stress. So, the value of our sigma would be equal to, parehas lang yung moment natin, 120. And then, kilonewton meter. And then, ang value ng ating C, yun yung mapapalitan. Ito na ngayon. Kasi nga, papuntang bottom eh. So, that's 128.85. 128.85 millimeter. So, ating conversion factor, that's 1,000 times 1,000 is 1 million, which is also the same as 10 raised to 6. Divided by, ito, 56,270,032.29 millimeter raised to 4 are the value now of our sigma or the bending stress at the bottom would be equal to 274.78 megapascal or Newton per millimeter squared. Okay. Alright, ngayon bis, makikita natin, meron tayong dalawang sagot, right? So, ang bending stress sa taas would be 151.78 MPa, while at the bottom, 274.78. So, di ba, hindi sila equal. Ngayon, i-sketch ngayon natin yung ating stress distribution. So, kung makikita nyo, this is our T-beam, yan. Ang stress distribution yan would look something like this. If this is our neutral axis, no? That's our neutral axis. At the top, no? At the top, there is a compressive stress, which has a value of 151.73. So, ayan, 151.73 megapascal, where this is in compression. Sa baba naman, sa bottom, mayroon tayong tension, which is a value of 274. So, syempre, mas malaki yan. 274.78 megapascal. which is in tension. And we will just connect these two lines. And palagi, sa neutral axis, there is zero stress. Okay? So, sa tanong natin, what is the maximum bending stress? So, the maximum bending stress is 274.28 MPa. Pero kung sinabi niya na, what is the maximum compressive stress and maximum tension, then we will have two answers. This is the maximum compressive stress and the maximum tensile stress. Pero in general kasi yung pagkasabi niya what is the maximum bending stress? Therefore, we will have 274.78 megapascal as our answer. And yung next question, draw the stress distribution. This is the stress distribution, mga bis. Okay, so kung mapapansin nyo mga bis, no, yung ginamit lang kasi natin is maximum positive moment. Kasi wala naman tayong negative moment, diba? So, kapag meron tayong negative moment, edi apat na yung i-compare natin. So, we will again solve something like this, pero papalitan lang natin yung value ng m na to, which is 120, kasi magiging negative moment na siya. So, ayun, I will show you an example sa ating susunod na mga videos comparing 4 different answers to find for the maximum bending stress. Okay, so ayun mga beast, here's a look for the better looking answer. Ayan, yun po. Makita nyo, 128.85, tapos 71.15 yun. In compression yung sa taas, in tension yung sa baba. The maximum bending stress, of course, is yung dito sa baba, 274.78. Ayan mga beast, no? So, ayan, maraming salamat kung nagstay ka dito hanggang sa dulo. If you have some clarifications or questions, drop it down below and susubukan ko ang aking makakaya para sagutin kapag meron akong oras. And ayan, kung sa tingin nyo meron akong pagkakamali dito or anything that could make this easier, comment down below na lang yan para makatulong sa ating lahat. So ayan, please like, share, and subscribe. Muli ako po inyong bubuyog na nagpapalala sa inyong maglakbay, mag-enjoy, maglaro, manaliksik, maging matinik. Jabi out.